Welcome to Fundamentals of Computers lecture series. This first session is about why we should be considering and learning the fundamentals of the computers before we can learn any of the programming languages. That also defines the objective of this session. We want to understand the importance of the fundamentals of computers for effective programming. Shown is the sequence that we will follow. We will first look at the definition of programming. Next, we will look at a sample program and a couple of sample codes. Then we will go through the steps of understanding why it is important to learn the basics. Finally, we will go through the path that we'll be following while we will be going through and covering the fundamentals of the computers. So, what is programming? Computer programming is process of writing instructions for the general purpose computers and defining the execution sequence of those instructions such that the instructions executed in specific sequence can achieve the tasks that we want to achieve from our programs. So a general computer program consists of two types of instructions. First type of instructions are the instructions that perform certain tasks. Example of the instruction is adding two numbers or assigning a value to a specific variable. Whereas the second type of instructions define the control sequence. So in general, our programs do not execute sequentially. The sequential execution would be starting from the first instruction and continuing to execute the instructions that keep on coming in the next step until we reach the last instruction. But the general purpose programs do not execute in sequence. They hop around and execute a set of instructions and then move on to a different portion and execute a different set of instructions. And the hopping around is done through the instructions that change the execution sequence. The tasks that we want to achieve from our programs can be as simple as just adding two numbers that we generally perform through a calculator program, or they can be relatively complex tasks, for example, performing the spell check over a document that we have written. Let's have a look at an example program. Suppose I create something like current is weekday, which can also have an alternate value of weekend. Okay, then I can write a statement like this: if current day equals weekday, then reach office by 9 a.m. else. Enjoy. So this is a very simple program. All the lines that I have written are actually instructions. So all of these are one instruction at a time as far as high-level language is concerned. These two instructions are sequence defining instructions, whereas the remaining 3 instructions are general purpose instructions. Why are these two sequence defining instructions? Because if you notice, the sequential execution of the program will be this instruction as first, then this should be executed, then this instruction, next should be this instruction, and last should be this instruction. However, when the execution is done, if the current day value is a weekday, then we will be executing this instruction, but we will skip this instruction. On the other hand, if current day is a weekend, then we will not be executing this instruction. So this instruction will get skipped. So our new sequence will become 1, 2, and after this we will be executing this instruction. So this else will become true. So this will be our third instruction, and this will be our fourth instruction to be executed. We will not be executing this specific instruction. So that is what we mean by sequence definition. And it depends upon the variables and the way the programs are written. So this is the crude way of writing the programs. What should be noted here is that the kind of instructions that I have written, that roughly matches to the arguments that we have daily. So we don't notice them always, but roughly this kind of statements we are making almost daily. If this is the condition, if it is raining, we will not go outside. If it is not raining, it is sunshine, we will go outside, and equivalents of that. So this is an example of programming. Now let's look at a real program, and then we will try to see the code of that specific program. This is a very simple calculator application. The calculator has different views. So this application shows the basic view of calculator, and it can perform all the functionalities that a normal calculator can perform. And so on. So it's a basic application that has been created using a programming language called Swift. So we will have a quick look at the code of this application and see how this application has been programmed. The screen shows a part of the code of the application. The entire code is relatively complex, but there are a couple of things that can be seen over here. There are some very common and very basic operations. For example, the division on the calculator application is simply being performed by dividing the first number that is entered with the second number that is entered by the user. Similarly, the operation of multiplication, subtraction, and addition is being performed. In addition to this, you can notice the assignment operator here. So basically, display dot string value, whatever it represents, is being assigned a string which is a multiplication of first number and the second number as shown over here. And similarly, the string value is being assigned. So this assignment is operator is the same operator that I used in the short program that I wrote a while ago. Another example of assignment operator is shown over here. Second, we can notice the if statement over here. So if, and there are few options that are being considered. I'm not going into the details, but I want to show that similar kind of instructions that we just saw are being used in this program as well. So there is if operator. Along with that, we have else statement, which is actually an else if statement. So the code roughly has similar kind of instructions that we just discussed a while ago in the example code that we have written. The application that I just showed and its code was the Swift code. Similar kind of code can be written in other languages. Generally, the basic constructs and the basic logic of the programs in different programming languages that are used for different purposes is same, with a difference in terms of the syntax and the semantics. So we cannot say it's 100% overlap. There are some differences, but there is a basic mechanism of writing the code. There are basic constructs of the logic that we use to write our code. So let's have a look at an alternate language which is known as R. So we will have a look at R programming languages code, which is used frequently for the data analytics. It's a data science language and it's used for the data analytics. This is the basic console for R programming language. Here I have written a very trivial kind of code which does not do much. A value of -5 is assigned to the variable x in this statement. So this is an assignment statement, just as we were writing the assignment states in Swift language, or we wrote the assignment statement in the example. Notice that the syntax here is different from the previous syntax. Next, we use the same if statement to check the value of x against 0. If x is greater than 0, then we print non-negative number, else we print negative number. So same kind of if-else construct is being used over here. Similar kind of assignment statements are being used over here. If we execute this program, we will see that it prints negative number because -5 is less than 0. Next, we are going to have a look at Node.js code. Node.js is a JavaScript server-side programming language, and it is generally used to create web applications and the front-end interfaces and back-end applications for the cloud applications. So let's have a quick look at the Node.js code and try to see if we can find some similarities between the Node.js code and the code that we have seen for R and Swift language. This is the backend of one of the websites. If we look at the routes portion, we see that there are few JavaScript files available over here. Let's try to open one of them. And what we see here is the Node.js code for this specific application. The code is relatively complex and long, but if we look at the last portion, we can see that we have used an if-else statement here as well. So if the environment is production, then these three statements will get executed. Otherwise, these three statements will get executed. Okay, so the code of the languages is a part of the code is common. It's just the syntax that varies. So once we understand how the basic logic of the programs is created, how the algorithms are written for the programs, then we should be able to understand the syntax and complexities of any language. Now that we have seen the code of the applications in three different languages, some of them trivial, some of them not that trivial, let's have a look at why we need to understand the basics of the computer before we can actually go for the programming of the applications. Doesn't matter what level of the programming we are doing. So why learn the computer fundamentals? One of the very important reasons is just to know what our programs do and how they perform those actions. Until and unless we have a very clear idea of how the programs are able to do what they are able to do, we should not be able to program at a level where we will feel confident that our programs will work under different scenarios and under different conditions. Second point, we need to write the code that works where it is supposed to work. If we don't understand the internals of the computer, there are a lot of chances that our code will not work as we expect it to work. And I'll show an example of a code that is not performing the task that it was supposed to perform. So we're going to see that example in a while. Next thing, we want to write the code that stands out. If the codes are written in a proper algorithmic way and with the understanding of the fundamentals of the computer, then our code is generally very, very neat, as well as performing the tasks that it is supposed to perform. So let's have a look at the example of the code that works, actually example which shows that the code that was supposed to perform a certain task, but it does not perform that specific task. Here I have shown I have logged into a physical computer named Edge, and I am showing the two different terminals for the same computer. And I have created a program named timer.c over here. So let's have a look at the source code of this program. I have carefully written a loop here. It runs for approximately 1 second. So this is a mechanism that the new programmers often use to create the timers in their programs, to create the delays in their programs, and they expect that this delay will remain uniform. It is not a good practice. It's not the code that should be followed. For every loop, I print the time passed because I expect that the time for this loop will be approximately 1 second. That is how I have timed the loop. That is how I have selected this specific value. So I just keep on saying that 1 second has passed. Along with that, I try to measure the time that the computer gives to this specific program through the time command. So we're going to run this program standalone, and we will see what exactly happens with our code. I have already compiled this program, so I'm going to run this program through time command. So the program starts and it starts printing the time. So it says that 1 second has passed and actual clock time has also moved by 1 second. Then 2 seconds have passed, but actual clock time moves by 3 seconds. So from this point onwards, there is just a minor difference of 1 second, but the clock keeps on moving forward. And notice that when the loop says that 10 seconds have passed, the clock time that the processor has given to this program is 12 seconds. Okay, so I can say that there is a little bit of tuning that is required. And the real time that has passed is 11.516 seconds, which is a little less than 12 seconds. So I can say that, all right, I can adjust the value of the loop here. I can decrease this value a little bit, and then I will be able to get exactly 10 seconds value. That is not something that I'm going to do right now because this time is not going to be accurate. What I want to show here is that if I run some other programs right now, exactly the same program on this computer. So I will execute this in a while, and along with that, I'm going to run this same program here the way I ran just a while ago. Okay, and we will see the difference between the two executions. The execution that was done over here, where 10 seconds passed mapped onto approximately 12 seconds, which I can tune. The real time passed was 11.516 seconds. So I'm going to run this because I expected that, okay, for every 10 seconds, the 12 seconds would have actually passed. Okay, so I'm going to run this program again while I'm creating some additional programs at the background. Let's see what kind of result we get. So we are not concerned with this second window that is being shown over here. This is not of our interest. All we are interested in this window. So notice that same program that previously executed in 11.516 seconds, while the clock showed 12 seconds, which we can say is the rounded up figure for 11.56, now shows 15.54 as the value, and the clock time passed is 15 seconds. So if I was using the for loop that I have created over here to measure the time in seconds, notice that without changing anything in this program, the result is different when I execute the program under different conditions. When I execute the program without these programs running, my time is different. When I execute the same program while these programs are also running in parallel, then my result is different. And I will not be able to pick this up if I am testing my code on a single computer where there is no additional load, and if the results change because something else has popped up on my computer for whatever reason, maybe I have started browsing at the back end, my results will start changing the way they are changing over here, and I will have no idea why my results are changing. This information can only be extracted if we exactly understand how the computers work and how they perform their tasks. Specifically, this issue is coming because the processor of the computer is being shared by multiple programs. There are few programs running over here that are sharing the processor with this specific program. And that is why the performance of my program is fluctuating as the load of the alternate programs increases or decreases. With the no load, I get a different value. With some load at the back end, I get a different value. So how do I understand what will be the effect of load, how the things will change? If I understand the impact of the load, if I understand the impact of the computer's RAM and other factors, then most likely I will not be writing the program the way I have written. Okay, so therefore it is very, very important to understand what factors affect our program's execution, and that is only possible if we understand at least some of the basics, some of the fundamentals of the computers, so that we can see how our program is getting affected because of different factors that exist on different computers. This brings us to the point where we should be appreciating the fact that without the fundamental knowledge of the computers, we will not be able to program. Efficiency is a different thing, but even the correctness of the program will get affected if our understanding about the computers is not good. So we will be studying the fundamentals first, and then we will go on to specific programming languages and the higher carriers that are possible and the higher level lectures. The path that we will take through the fundamentals is roughly as follows. As far as this set of lectures is concerned, the fundamentals of computers, we'll be looking at binary numbers. Then we'll be looking at binary logic, logic to computer operations conversion, link between the computer operations and the computer instructions, and computer instructions to programs. This portion will generally be one session each. Then program segments, their role in the program. That will be followed by the computer components, for example, RAM, CPU, cache, hard disk, and their role in the program execution, and the program execution, multiple program execution, and the role of operating system in multiple program execution. This set of lectures will probably take more than one session per topic. So I'm hoping that somewhere between 10 to 12 topics, each 10 to 12 sessions, each of approximately 20 to 30 minutes, and we should be able to cover the fundamentals of the computers. The next topic that we will be covering, next course that we will be going through is algorithms, and then we will look at one specific programming language. From that point onwards, we will diversify the possible set of lectures that are and the possible set of careers that are possible beyond this basic set of sessions. I recommend that everybody who is going to go through the subsequent sessions must go through this initial set of sessions, specifically fundamental of computers and algorithms. Next lecture in this series will be about binary numbering system. With that, our current session comes to an end. If you or anyone around you has benefited from our sessions, please support us on Patreon so that we can continue our effort. Thank you and have a nice day.